Okay, we're going to deal with two things in this video. One is going to be how do we do all four tasks in one file, and the other part is going to be dealing with task 4. So here's that standard online GDB that I've modified just a little bit. So put your info in here, what it is you're doing, why you're doing it, when you're doing it, who you are. Don't forget your personalization. And we're going to include 3 different libraries. Standard IO, Math.h, and for task 4, since we're dealing with discriminants to get it to run, we'll go ahead and deal with the complex numbers library as well. And that'll give us some functionality we can use. So beyond that, just come down and put comments in your sections showing here's the formulas for each task. So like I said in class, the formulas need to happen or they need to live before the main. So the main's down below. We need to declare or define these functions, however many we're going to have, prior to we ever get to the main. So as you work on task 1, set the formulas here, task 2 formulas in here, and task 3 formulas in here. And then just put a little white space in between so it's organized. So the task 4 formulas. So here's a formula to compute the intersection. And we started talking about this in class, but I didn't take into consideration the fact that we were dealing with discriminants and potentially going to be complex numbers. And then had we run them, we could have ended up with not a number for some of the results because of how I had this coded out. The gist of this task is not so much you being a master of trigonometry or coding. It's getting familiar with using functions, using variables, and understanding that we've got variables, we set values based on what we received, and then we build out the different calculations or formulas to perform a calculation. So here's our function, and we got through this in class, but what we didn't do, as I said in there, was deal with pointer dereferences, and that's what's happening here, and also also the discriminant aspect, where we're having to deal with complex numbers. So here it's a double, it's complex, and it's the square root discriminant that's getting returned. So we've got a lot going on in here. I want you to be able to understand, well, this says void. We've had other values in the past. That just means this doesn't return anything. So see down at the bottom of this function, there is no return. The value, if it returns, or data type of what's being returned, well, there is nothing being returned, so we say void. It's empty. The name of the function, and in order, each parameter being passed to our function. Data type, the fact that it's complex. Data type, the fact that it's complex. Okay? So that's what we're doing here. We're calling the square root, but it's a complex square root. And this is where it gets ugly if you haven't been down this path before. But like I said, it's not so much I'm testing you on the trig aspect, but dealing with the code. So as we come down, we get into the main, open the main up, put a little printf in there, and print out new line, task 1, new line. Give yourself some space to deal with task 1. Say task 1 output. We'll replace this with whatever output, or you could put another line down below it with your task 1 output. Then you move on to task 2. Same thing, task 2 output. Whatever you need to output for task 2. Same thing with task 3. Put it in there, and then your output. So, the thing that I don't have in here yet would be this line. I could put it anywhere. We'll put it in there. So task 4 output. We defined doubles, the 4 complex numbers x1, y1, x2, y2, to be able to do our quadratic equation. And we used this math to be able to do it in our calculation. So we go through, here's the first one, the first line that we had. Where does this intersect with what we were given, our default values, and we input those up here. Here's our y, here's our x, our y, and the radius. So here's where we're at. We call or invoke that function, pass it to 0.5 for the x parameter. Our y parameter is 1. Each one of the values, these are pointers, x1, y1, x2, y2. So we pass those over. From there, we just run it. It returns the value or not. It really doesn't return the value. It's doing it here. So these are pointers to an x1, a y1, x2, and a y2. So we're reserving a space in memory for each one of these. Up here, we see x1, y1, x2, y2, complex numbers. So we're reserving a space in memory, and that's what we're pointing to. So when you see this right here, what we did right there with that asterisk in front, it's just a pointer to a place in memory. This allows it, in a sense, to be global. We're just pointing to x1 in memory, and it's being changed everywhere. So anytime we're dealing with x1, it's being changed or modified there. We won't use this much, but for this, I thought it'd be a decent place to see how complex these things could get. And yet complex, these are, most of them, complex numbers. Complex real, complex imaginary, complex real, complex imaginary. So we go through and deal with each of the values, and we end up with the intersection points. And when this is run, as it stands now, task 1 output, task 2, and I could go in and put task 2 output in there. Let me go run it again. It ran it. There's our task 4. Let me go put a new line after this, \n, run it again, and there's a little cleaner. Task 4 output, there's all our outputs. Had we gone through and done this without dealing with the complex numbers, we'd have had not a number, likely on one or maybe more than one of these. So there's one way to go about this, and it's just the math part of it. There was one of your fellow students asked me, when it came to finding the height for, what was task 2, we didn't need to necessarily find the height, we needed to find at what degree were we sure we were going to get over that 6-foot goalie. So instead of finding the height, he went about it the other direction and found the degree. And it was just doing it the opposite direction. So with all of these, there's more than one way to get to whatever the result we're looking at, depending on how we're perceiving the problem. And like I said, that's what the goal of this is, to get exposure to dealing with the functions, understanding what the variables are, getting familiar with how calculations work and the built-in functions and where they're coming from. Okay. If you have any questions about 1, 2, or 3, shoot me a message in Canvas and I can clear up anything that you may have had a problem with after the discussion in class today. Okay. So I'll see you Tuesday, and like I said, reach out in Canvas if you run into any problems.